Hello! Today we're going to be solving linear equations, and this is a learn by doing exercise, which means that instead of just watching me solve the problems in the video, you're going to be helping make the decisions for how we solve these problems. We're going to do 3 problems now, so let's jump into it. Solve 7x minus 1 equals 20. Now, we know that the goal in solving this equation is to get x alone on one side of the equation. To get x alone, we're going to have to get rid of the 7, and we're going to have to get rid of that 1 as well. So my first question for you is a two-parter. Which should we try to get rid of first, the 7 on the x, or that other term that's got the 1 in it? And why should we make that decision? In this case, we want to get rid of the 1 first. And the reason for that is if we wanted to get rid of the 7 is being multiplied by x, and to get rid of that, we would have to divide by 7. It's the opposite of multiplying by 7. And if we divided all of these by 7, we would end up with a bunch of fractions. We don't want to end up with fractions, so when division is one of the steps in solving a linear equation, we want to save that for the end. So in this case, we want to get rid of that 1. What can we do to both sides of the equation to get rid of this 1? Since 1 is being subtracted from 7x, the opposite of subtracting 1 is adding 1. And so what we're going to do is add 1 to both sides of the equation. On the left-hand side, that negative 1 plus 1 is 0, so they cancel out, and we're just left with 7x on the left. On the right, 20 plus 1 is 21, so we've got 7x equals 21. We've got one more step to get x alone. We need to get rid of the 7. How do we get rid of the 7 here? Since x is being multiplied by 7, to undo that multiplication, we do the opposite, which is divide both sides by 7. When we do that on the left, 7x divided by 7 is just x. On the right, 21 divided by 7 is 3. And we've got our solution, x equals 3. If we want to check to see if it's correct, we can substitute that into the original equation. So we've got 7 times x, but we know that x is 3. So 7 times 3 minus 1 equals 20. We want to check and see if this is correct. 7 times 3 is 21. And we do know that 21 minus 1 is 20, so it checks out, and we know that 3 is our solution. Let's move on to the next problem. Solve 5y minus 3 equals 3y plus 7. There are several ways that we could go about solving this equation, but we have variables on both sides of the equal sign, and so I want to focus on that first. Our goal is to get the variable alone on one side of the equation, and so here we've got the variable on both sides. We need to do something to get the variable alone on one side of the equation. Which are the 2 different options? There's 2 answers here. Which of the 2 options will allow us to get the variable alone on one side of the equation? Now there are 2 different possibilities here, and I actually want to look at both of them. The first possibility is that we could subtract 5y from both sides of the equation. What that does for us is it cancels the y terms on the left-hand side, eliminating y from the left. When we do that on the right-hand side, 3y minus 5y is negative 2y plus 7. And the other option is that we could focus on eliminating the 3y on the right. To do that, we could subtract 3y from both sides. When we do that, that gives us 2y minus 3 on the left. And on the right, 3y minus 3y is nothing, so those go away, and we're left with 7 on the right. Now, either of these options works because in each of them, we've eliminated one of the variables, and so we're left with y on only one side of the equation. However, I recommend this second option, and that's because this one gives us a positive 2y, whereas the other one leaves us with a negative 2y, and the more negatives that we have, the more difficult the calculations will be. Not that much more difficult, but the more negatives there are, the more often students make mistakes. So either of these would work, and we will get the correct answer if we continue using either of these, but I want to focus on the second one here. So we want to get the y alone. To do that, we need to get rid of this negative 3. To do that, we're going to add 3 to both sides. On the left, that leaves us with 2y. And then on the right, 7 plus 3 is 10. And now we have one more step. Can you do this step on your own? Tell me, what do we get when we solve for y? Well, the last thing we need to do is get rid of the 2 in front of the y. We can do that by dividing both sides by 2. And when we do that, 10 divided by 2 is 5. So we end up with a final answer of y equals 5. If we want to check if that's correct, we can substitute that into the original equation. I will leave that as an exercise for you to do on your own if you want more practice checking your answers. Also, you can continue working on the first option, and you should still get the same answer. But for right now, I want to focus on one last example. Solve 2 times the quantity z plus 5 minus 7 equals 3 times the quantity z minus 2. Here we have grouping symbols, and in particular, we have numbers in front of the grouping symbols. And so we recognize this as a situation where we need to use the distributive property. On the left-hand side, if we distribute the 2 to the terms inside the parentheses, we get 2z plus 10, and then we still have the minus 7. On the right, what happens when we distribute the 3 to both of the terms in the parentheses? First, we multiply 3 by z to get 3z, and then we bring down that subtraction, and then 3 times 2 gives us 6, so we end up with 3z minus 6. Good. Now at this point, what can we do next to simplify things? We notice on the left-hand side that we have like terms, so we can combine these like terms to make the equation simpler. That gives us 2z plus 3, because 10 minus 7 is 3, equals 3z minus 6. Now at this point, we find ourselves in a situation where we have variable terms on both sides. What can we do to eliminate the variable term on one side while also making sure the result gives us a positive coefficient on the variable? In this case, we can eliminate the 2z on the left-hand side by subtracting 2z from both sides. And when we do that on the right, 3z minus 2z is 1z, or just z. And because that has a positive coefficient, we like that more than the other option. Now, on the left-hand side, 2z minus 2z is 0, so those cancel, and we're just left with 3. All right. We've reached the home stretch. There's one more step. Can you do that step and tell me what the final answer is? To get rid of that 6, we need to add 6 to both sides. When we do that, 3 plus 6 is 9, and we're left with z alone on the right-hand side. So our final answer here is 9 equals z, or if you like it better, you can switch the two sides and write z equals 9. Either one works. The last thing I want to point out is that all of these problems had whole number answers. That's not always going to be the case. Because we're just getting into the swing of things, I wanted to make sure that the answers looked nice. But as you work on more complicated problems, and depending on who your instructor is, you might have answers that are quite complicated. You might have fractions. You'll have negative numbers. So right now I kept it fairly easy, but you should not be afraid of answers that are negative numbers or fractions, because they're certainly possible, and you will be seeing those in your algebra classes.